So in this unit, to find the precise definition of a limit, we're kind of extending that intermediate value theorem. So our intermediate value theorem says that if I have a continuous function, that between any two specific x values, a and b, there's going to be some value in between c that gives me a value L. That was our intermediate value theorem. The precise definition is saying that we assume that f of x exists for all x's in some open interval containing a, except maybe a, and the limit of f of x as x approaches a is L. For any number epsilon greater than 0, there is a corresponding number delta greater than 0 such that two things happens. The absolute difference between the function and L has to be less than epsilon whenever the absolute distance difference between x and that a value is between 0 and delta. That seems really confusing, so let's look at a couple. Alright, so what this one is saying, it's saying we're looking at a graph, and we want the function f in the figure is satisfying the limit as x approaches 2 of f of x equals 5, because when x equals 2, the y value is 5. Okay, and it's coming from the left and the right, it equals 5. So now we want to use our definition of a limit to help find out what is the delta value that makes that always true. So if I'm looking at this part, the absolute value of f of x minus 5 is less than 2. If I were to rewrite that without absolute value bars, that would say negative 2 is less than f of x minus 5, which is less than positive 2. And if I solve, I add 5 to all my pieces. I have 3 is less than f of x is less than 7. And so when I look at this graph, here's 3, here's 7. So I'm now going to focus, so it's saying between those values, 5 is between them, there is also a delta value that keeps my x's within that to work on the graph. And so showing that, here I see right here on the graph, and right here are those points on the graph that exist, so those values, and I'm going to drop those down to my x-axis, and I can see, okay, from 1 to 3 is the change in my x values, and that's all delta is talking about. What's the change in x? How big is delta allowed to be if I'm starting at this particular value 2? So I went up 1, and I went down 1. So this tells me that my delta value, the biggest it can be, is positive 1, when the difference in my y values is positive 2. Okay, same graph, same everything, except now we're going to shrink what that epsilon value is. Instead of being 2 away, we're looking at part B here, and the difference between any function value and 5 has to be less than 1. So that means, without writing it down, if I'm at 5, I can go up to 6, or I can go down to 4. And my corresponding y values here are right here, right? That's where the graph's hitting those y values, and those correspond to these x values, which are now closer to that 2. Notice I went up a half and I went down a half. So in this case, that delta value would be positive 1/2. So we're trying to kind of mimic, and we're squeezing in that intermediate value theorem, saying how far away from that value can they be that this still works. All right, let's try another one. Same exact idea, but completely different graph. Here it says the limit as x approaches 3 of f of x equals 6. So at x equals 3, the graph equals 6. So we want to know what is the largest value of delta that will make the statement true, so that we really know that limit exists, which we do. So it's saying the absolute value of f of x minus 6 has to be less than 3. So that means I can be 3 above or 3 below. And I look at the y values right there. I find those points on the graph that meet those y values, and then I'm bringing them down to my x-axis. So I know when x equals 1 and when x equals 5. Well, we want to know, for our delta, how do those compare to 3? Well, notice 5 is 2 above, 1 is 2 below, so my delta value is 2. All right, again, same graph, except now we're shrinking it, and we're saying the difference has to be in my y range, 1 above and 1 below. So I draw 1 above, I draw 1 below, I find where that is on my graph, so I find these 2 new points, and I drop them down to see what those x values are. And I can see here from 3, I'm about a half above and about a half below. So in this case, my delta value is 1/2.